Hello everyone, I am Ayusha and today I am excited to present our project for the Smart India Hackathon titled Optical-Guided Super-Resolution for Thermal IR Imagery and Problem Statement ID 25171, which is under the organization of Indian Space Research Organization. This application aims to transform low-resolution thermal image into high-resolution detailed thermal image guided by optical data to assist various fields. Thermal sensors are often capture low detail image, while optical sensors provide rich texture. So why not to use optical image to enhance thermal image? This is what our project is. Now let's move on to our landing page. This is our landing page. Our project is named as Stellar Vision X. Welcome to the Stellar Vision X portal, an advanced intelligence AI powered platform which has analysis tools to help with the image process. Now let's log in onto our portal. This is our portal. The journey begins at our secure login screen. User can log in with their registered credential. Also, they can log in with the Google button. If you don't have account, no worries. You can create one by filling and submitting the form here. Now we will log in. Boom, we are logged in now. Once inside, user is greeted with modern dashboard displaying user stats. It is here, quick actions and related activities. If any hotspot is detected, it will show here as an status of warning. Now to upload image, we can click here upload optical image or we can use sidebar 2. Now we will upload optical image here and low resolution thermal image here. By clicking on Run Fusion, our system performs geometric alignment between both images, ensuring they are perfectly co-registered. Within seconds, our algorithm prepares the data for our fusion. Here we can see the accuracy of our fusion is 94.8%. We have provided a side-by-side comparison too. Below are all the metrics of the task performed. We would like to take a screenshot of this to compare it with the reports which we will see further. We can perform operation as download enhanced image. It will download the image as we can see here. We can view detail matrices. We can visualize heat map too. Now let's move on to our matrix section. This is our next module named as matrix. To ensure output quality, we automate compute metrics like peak signal to noise ratio, SSIM, root mean square error, edge preservation, and thermal fidelity. We can export this data into CSV format too. We can see the Excel file is getting opened. Here are all the details. Also, we can see the metrics in graph format and bar format too. Here is the main information which shows performance summary. We have an overall quality score of 94%, which is very good. Processing time is 2.4 seconds, which is very less as our model is trained that much. And our model can enhance image up to 4 times. Now let's go on to next module, which is known as visualization. One of our favorite feature is the interactive heat map view, which is here. We also have image view. It translates temperature intensity into color gradient. Like blue, here are blue for cold region. Red, here are red for hot region that are known as hotspot. As we can see here, we can adjust the opacity overload and it will give real-time data output. We need to keep a note of everything we do. So here is reports and downloads. Here we can access and download processed fusion analysis report. We can see details like session count, last image generated, how many images are completed, and all the details. We can view the report by clicking view and it will open in new tab. Or we can download it in the TXT format by clicking on download button. Here is the report which is downloaded, which has all the detail, processing detail, matrix detail, its accuracy, name of images uploaded, and the time and the date and the session ID, which is very important. Remember, we took the screenshot of matrix. Now we will check here if the data is accurate and matched perfectly. Peak noise ratio is 32.41. Here it is correct. SSIM is 0.899. Here it is correct. RMSE is 2.97K. Here it is correct. Fidelity is whooping 96%. Very much perfect. Edge preservation is on scale of 0.90, which is close to 1. Again, it is perfect. Thank you for watching our demo video. More features are being added. I am Ayusha, and this was our project submission for the Smart India Hackathon 2025 under the Department of Space ISRO.